Okay, I'm going to start out this problem like I did the problem on the previous slide. We're going to look for variable terms that we can cancel out. So here what I see is, I see this negative 5y and this 5y that are opposites, but I also see this negative 2z and 2z that are opposites. So I'm going to make it my goal to cancel those out through elimination. So I'm going to write these down. Negative 2x minus 5y minus 2z equals 12. And negative 2x plus 5y plus 2z equals 4. When I go through to do this, again, that negative 5y and 5y cancel each other out. And negative 2z and 2z cancel each other out. They cancel because we're adding these two equations together. So I'm going to add negative 2x and negative 2x, which is negative 4x. And 12 plus 4 is 16. Now we need to get that x by itself. In order to get that x by itself, we need to do the inverse of multiplication, which is division. We're going to divide both sides by negative 4. We divide by whatever that coefficient is. That way, whenever we divide negative 4 by negative 4, we get 1. And we don't put a 1 in front of a variable most of the time, because it's just understood there's a 1 there, and that's what we're looking for. And then we have 16 divided by negative 4. A positive divided by a negative is negative, and 16 divided by 4 is 4. So now we've solved for one variable. So now I'm going to pick a different pair of equations. I want to pick a pair of equations where I have something that can cancel if possible. I'm looking at this first one and the last one, because I can see that negative 5y and 5y are going to cancel each other out. So negative 4x minus 5y minus z equals 18. And negative 2x plus 5y plus 2z equals 4. So we're going to add these together. That'd be negative 6x. Our 5y's cancel because they're opposites. Then negative z plus 2z is plus z equals 22. Now, I have two variables. I cannot just go on and solve for one of those variables. Well, I could, but it's not going to do me a whole lot of good because I'm still stuck with two variables. But what I can do is I could take this negative 4 and I can plug it in for x right here. When I do that, I'm going to get this. Negative 6 times z equals 22. Plug in that -4. Then my next step, I'm going to multiply that out. -6 times -4 is positive 24. So we have 24 plus z equals 22. Subtract 24 from both sides. And z equals -2. So now we have 2 of our variables. Our last step would be to take these two variables, these two solutions, the x and the z values, and I'm going to plug them back into one of these equations. It doesn't matter which one you plug them into. I'm going to go ahead and plug into this first equation again. I'm going to switch colors here. -4 parentheses -5 parentheses. Nope, not parentheses there because I don't know what y is. I'm going to leave that y there. That's what I need to solve for. Minus z we found was -2. I'm going to put that in a minute. Equals 18. Now I'm going to plug in those numbers. -4 for x. And -2 for z. Then I'm going to go through and simplify. So -4 times -4 is positive 16 minus 5y. And anytime we see minus negative, anytime we see this minus negative, we're going to change that to a plus. So we're going to do +2 equals 18. Once we're at this point, we're going to combine like terms. 16 and 2 will combine to be 18. So now we bring down our minus 5y equals 18. Move that 18 to the other side to get that -5y by itself. And you might be thinking, okay, well, what if I have nothing left on the right side? Well, 18 minus 18 is 0, which is fine. That's allowed. We can have 0. What we're going to do is just divide by -5. Both sides. Which gives us y equals 0. And that's how you'll solve a system of equations algebraically.